So from ice cream to connectivity, communications and connectivity. So my name is Rajiv, as Kathy introduced you. And I've been co-chairing the Connectivity Task Group at IIC since it was formed. I was the founding member of the Connectivity Task Group. I've been involved with the connectivity effort in IIC since the very beginning. So as part of the IRA effort, that really, I was asked to take a lead role back in November of 2014, and then so I've been involved since then. And then as part of my day job at RTI, Real-Time Innovations, I'm a principal solution architect, so I work with our customers, help them architect and design industrial IoT architectures, and really all from a connectivity perspective. So that's a quick background. And really for today, we are going to talk about really 4 key things for the agenda. So we're going to talk about how do we go from here to there. And by here, I mean Internet of People to the Internet of Things. And we're going to talk about connectivity versus communications versus interoperability and what these things mean. We are going to talk about some special demands that when you take humans out of the loop, you have on connectivity, because it needs to start getting a little bit more intelligent as well. So we're going to talk about the evolution of the connectivity stack. We're going to define a new layer called the connectivity framework, and we're going to talk briefly about that. And then we are going to talk about how do you define a long-term stable IoT architecture strategy. And that means embracing the old and the new and having an architecture approach that allows you to do that while also ensuring security and other good things that you want. And in order to do that, there's this notion of core connectivity standards to establish some criteria for that as well. So we'll briefly look at that. And then finally, how do you go about selecting the right connectivity technology? And so we've built in the connectivity framework a set of assessment templates. So we're going to look at that at a high level, and then we have applied those to evaluate relevant connectivity standards that again came from the IIC membership. And so we'll briefly look at that, and that's the agenda for today. So this is really going to be a preview. The document is available. It's for free. It's on the IIC website. If you go, I think it's still showing on the banner page of the IIC website. It's our latest document. So that's where all the details are there. So this is really just so how do we go from here to there, right? And so where are we? We are starting with the Internet of People. That's how we got the word Internet of Things and the industrial Internet of Things, right? IoT. But if you think about where this Internet of People comes from, it really comes from this. I call it the tin can communication model, really, and the telephone system is really an evolution of that. And then if you think about the web, it's also an evolution of that. And really, what's unique to it is that information is produced and created by humans and is consumed by humans. So really, the infrastructure has to do not too much in terms of being smart. All it has to do is faithfully move the information around, and the interpretation of that information is up to the humans. And as long as there's a common language, it all works. But then we want to go to this, which is the Internet of Things. And this is now machines talking to machines, it is vehicles talking to vehicles, and it is sort of smart devices and things that are communicating with each other. And what's different is that we've taken the human out of the loop. And when you take the human out of the loop, the question then is, what additional demands does it put on the connectivity infrastructure? And if you've taken the human intelligence out of the loop, then how does the connectivity infrastructure need to be smarter and intelligent and secure and so on, all those things, right? So that's the question we are asking. So and that's an important question to ask. So let's start by looking at some common words, right? So this word communicate, it's a verb. It's been around with us for about 200 years. And really what it means is to share or exchange information, right? So pretty straightforward. And then there's the word communication or communications, and it's derived from communicate. It's been around again for a long time. And it refers to the act of communication, right? Or act of communicating. So it refers to sharing or exchanging of information. And then there's the word connectivity and infrastructure and connectivity infrastructure. Now these are relatively new words. They've been around with us only since computers. And it's a noun, and it refers to the information exchange infrastructure. So, and then there's this word interoperability, and that's even newer. It's only been around for about 25 years, maybe even less. Okay, And this refers to the ability to not only exchange information, but also to make use of information. So that means there is some meaningful interpretation of that information, right? So we have, I drew it as a Venn diagram, connectivity, which you need absolutely to have communications, but just because you have connectivity doesn't mean you have communication. But communications requires connectivity. That's the infrastructure. But that, just having communications doesn't mean you have interoperability. So interoperability requires meaningful communications, right? So interoperability, which is really the end goal, so that we can not only exchange, but make use of information and we want machines and things to be able to do this autonomously with the human out of the loop. So interoperability requires essentially a suitable connectivity infrastructure for meaningful communications, again, if it's between people, then our tin can infrastructure or the telephone system or the World Wide Web and sort of technologies based around that idea, those sort of work. But now if you want to talk about meaningful communication between things, we have to raise the bar in terms of the level of interoperability that the infrastructure needs to provide. And this now puts a little bit of a demand on the infrastructure, so that is a little bit smarter, intelligent, it provides a little bit more capability there. So, and that choice of connectivity infrastructure has a fundamental impact on the ease of integration, on interoperability, on composability, and so on. The kind of things we want to do. This is what everybody dreams about, but the question is, how do we go from here to there, okay? So this is where IICF comes in. This is a comprehensive treatment of connectivity as a means of building interoperable IoT systems. We just launched this February 28th, and it's still flashing on the IICF website. We just put a blog out earlier this week, and then we have a webinar coming up April 5th. That's where you'll find a lot of the material. Now, this is third in the series of foundational documents that are laying the IIC technical foundation. And really, this is how things are coming together, right? So you have architecture as one of the key pillars of the IIC. You saw Shiwan talk about this earlier. Version 1.7, June, is where we had a chapter on connectivity. We expanded that out, and that's what we launched as the connectivity framework now. And then we had the version 1.8 come out back in January, and the security framework that was just released a few months ago. And you heard the panel here. So this is these are kind of the foundational pillars of industrial IoT. So what does IoT give you? IICF give you? So it's really about both theory and practice to provide useful guidance. So on the theory side, we're looking at the science of connectivity and building reference models, building assessment templates, and coming at it from a user's point of view. What do I need? What are the core functions? What are the typical considerations? What are the possible choices in my decision space? And then we look at the other side of the coin and we say, well, what does it mean from a practice point of view, and what does the reality look like? And the reality is defined by the landscape of standards and so on that are around. So looking at a technology or a standard from the lens of this theory and models, you can now start to see, well, how do things fit together, right? So the goal of the IICF is really to accelerate IoT. So it's about giving clarity when it comes to connectivity decisions, understanding the landscape of connectivity, providing a foundation and guidance. So, the clarity part is about, are you in a valley or a hill? It's a complex, rich, and sometimes confusing landscape, right? And depending on where you are in this landscape of connectivity, everything looks like, everything looks like a big mountain around you, or everything looks like, there's water everywhere. So it really depends on your vantage point, and really what we want to do is step back and say, well, there's this, there are all these different considerations, and this is a very rich landscape. So just bringing that out, that's one goal of the connectivity framework. The second is to have a stable long-term foundation that for IoT interoperability. So that's the other side of it. And then the third side is, how do I put all of this together to have something practical and tangible that I can apply today, and so that I can make technology selections and evaluation and so on. All right. So let's take a look at the evolution of the IoT connectivity stack. So some of you may have seen this picture. It's been around for quite a while. There are several interoperability models. This is one of the popular ones. And this has come about really from other domains. There's a link there at the bottom to Wikipedia, and it defines these levels of interoperability. Level 0 means no interoperability. Okay, so not too interesting. Level 1 means technical interoperability, and that refers to there's a compatible means of signaling and protocols. I'm speaking, there's a sound signal, and it reaches your ear, and you can listen to me. So, that's technical interoperability. And then the next level is that there's some structure of the data that's also being shared. In this case, you are understanding the words of the English language, and of course you understand the semantics, so that's the third level. So, and then you have some context of IoT, so you can understand what I'm saying, but maybe not everybody will, right? If I step outside the room and start giving this talk, we'll probably not have this audience, right? So there's all this context that you need for meaningful communications, for interoperability. Right? Now, historically, if you look at our space, industrial IoT, people have been doing this because this is sort of fundamental, but they have been doing this in vertical silos. It's very specialized, so the SCADA people, for example, say, well, I need to solve this problem, and I will build my model, and based on that, I will optimize everything in the stack. Right? Same thing in medical, same thing in utilities, and so on. So there are all these very specialized stacks that have been built, but what they do is also lock sort of the communication out, in that vertical. And what we want to do in terms of where we want to go and build this, ecosystem of machines and autonomy around us that can. So we want horizontal interoperability. So you want a horizontal stack that can span multiple verticals and provide a level of interoperability across verticals. So how do we go about doing this? Now, in the past, as I've been talking about this and we have been discussing this, many of you have come to me and said, can you give me an example? So I, being a system architect, I just pulled out my toolbox and I said, okay, let's put some traces out. So this is a trace of just message communication. And you can see that between these two endpoints, you are just exchanging byte sequences or byte streams. Okay, this is, in this case, there's no context being maintained beyond this byte stream between the applications. And so if a third party wanted to join this conversation, they would have to understand what these bytes are. On the right, you see the ASCII version of the printable characters. On the left, you see just the byte stream here. Right? So if you didn't know how this was organized, you couldn't participate in this conversation. So that's the level of technical interoperability. Like my kids sometimes make up their own language so we don't understand, right? So same idea. Right? So we know they're talking, that's all we know. But then the next level is, what does the infrastructure maintain for me? The next level is, the infrastructure is also not just maintaining the ability to share this byte stream, but it is also maintaining the ability to share structured data types. So now there's some notion of data objects, there's some notion of identity of objects, there's some notion of structure of objects. In this example, I have a data object here with a string and two numbers. The string happens to be a string that can be sized up to 128 characters. The numbers happen to be long instead of floating point. So this is now something that the infrastructure, the connectivity infrastructure, is keeping track of. And now a third party could join and at least understand the structure being exchanged. Right? So this is a little bit more intelligent. The next level of this would be semantics. Well, what does this structure really mean? Does the structure with the string, with these, does it mean the color of my car? Does that string mean the color of my car? And does the X and the Y mean the row and column of where my vehicle is parked in a parking lot? Or does that string mean, the color of my room and the X and the Y refer to the temperature and the humidity, right? So that's semantics. And again, and the infrastructure could also maintain that information, that additional context. Now, as you want to have more meaningful communications and interoperably, you need to keep going up. So kind of gives you a feel for what I meant by those three levels of interoperability, right? So now the next question is, well, where do we draw the line? And well, we start here with messages. So this is pretty well understood. That's why this whole Internet of X, Internet of Things, started, an industrial internet. And then there's structured data exchange. So these are levels that are fairly well understood at this point. So we can check them off. This layer is still research. There are many different ideas here. It's still evolving. There are many techniques. There isn't sort of established standards out there, certainly not in this space. So we said, well, we'll draw the line right here, at least for the purposes of our task group and for defining the connectivity framework, and we'll say, well, this is as far as we'll go in the connectivity stack, and then we'll have a higher bar that is more suited for industrial IoT, and then we can start building on that foundation. So we're kind of setting a higher bar for connectivity here, right? And there's a lot of sort of previous work that has gone into this. So those of you who've been around and in this space, know that there's the 4-layer internet stack layer model, right? You've probably seen this. This is it came out around 1989. This is the internet stack model. Then there's the 7-layer OSI model, which you guys have probably seen already also in the past. It's there in the literature, and that was about 1994 timeframe. And what we did was we looked at those two models, and then we looked at IoT considerations, and then we came up with this IoT connectivity stack model. So those two models don't define too much above the network layer. And what we defined here, really what's new, is the connectivity framework layer. And if we go bottom up in the stack, the physical layer is really just about exchanging bits. It's like the sound signal, right? And then the link layer is exchanging frames, which are collections of bits. So sometimes these are called access layer technologies. And then network layer is about exchanging packets, and that's really, the IP or the internet layer, as sometimes people think about it. But that's really the abstraction that allows you to connect different access technologies together into an internet or internetwork, right? So that's the network layer, and that's the neck of the stack. There's innovation happening below that, and there's innovation happening above that. So for the purposes of this work, we kind of recognize that networking is relatively well understood in the domain, because that's how this whole space has started. That's how this movement has started. So, well, this is generally understood, although there's a lot of innovation happening at this layer as well. But we're going to keep that out of the scope for this document, and then we'll focus on the layers above that, because that's exactly what impacts integration and interoperability and development. So we focus this document really on these layers and spend more time refining and defining the connectivity framework layers and the transport layers. And what these are about, the transport layer is about technical interoperability, level 1, I give you an example, and then syntactic interoperability is in the framework layer, and then we have semantic interoperability, which we conveniently pushed out sort of outside the scope of this work, but it's being tackled by another task group, and we are looking for a white paper at some point from them. So look out for that, but they're building on this foundation now at this point, right? So we drew the line right there at the framework layer. And so how we see this stack looking like for industrial IoT is, you've got the network layer, whatever that happens to be, and then the transport layer providing technical interoperability, and then the framework layer providing syntactic interoperability, and then that's where we drew the line on the connectivity cross-cutting, and then the semantics, and then the applications and analytics can be built on top of that. So that's more meaningful interoperability, and then you can have many different verticals on that same horizontal foundation. So this is the idea behind the connectivity stack. So let's take a look at each of these layers really quickly. This one is about syntactic interoperability. So I'll just talk about the framework layer a little bit here. So as I said, it's about sharing structured data types, and what that means is information is structured in unambiguous common data format. And meaning, semantics is beyond the scope of this layer. But what this layer should be able to provide, and this is what the infrastructure is maintaining, is the ability to participate in a conversation independent of a programming environment, independent of the compute platform, and really allow anybody to participate in that conversation, assuming, of course, they have the right credentials, and letting the infrastructure optimize the delivery of information and data. What are the core functions of this layer? Well, as you can imagine, one of the core functions has to be built around the data model, right? So there has to be some way of modeling data objects or data resources. So everything is anchored around there. And then you need some way of identifying data objects, some way of addressing them, some notion of a type system to describe the structure of data These could get quite complex in these type of systems. Some way of managing the life cycle of data objects, and this word CRUD, you guys may have seen it, stands for create, read, update, delete. So it's how do you manage life cycle of different data objects, and the state management, for example, disconnects and history and so on. And then there's this notion of quality of service around the data. How do you manage sort of behavior of the data, and then again, this is defined in the IICF, and security, of course, around data. And then there are many ways of interacting with the data. So, many systems require a publish-subscribe interaction pattern. Many of them require request-replies, so those are different interaction patterns, some way of discovering, some way of handling exceptions, and so on. And then, of course, some way of having a way of accessing this. So there's an API aspect as well to it, and could be many styles of APIs, and then some governance aspect to it as well, which is more the configuration and management side of it. Okay, so let's go to the next layer, which is which is providing the technical interoperability, and this is the connectivity transport layer. So here, its function is only expected to be sharing of byte sequences, like I showed you in that example, and the structure is outside the scope of this layer at this point. So again, this should be possible on any compute platform, any programming language again, and this can again optimize the delivery of byte flow. So some of the core functions here are a messaging protocol, communication modes, unicast, multicast, those sorts of things, some way of addressing an endpoints, connectedness, prioritization, timing and synchronization, security at this level. So again, I won't go into too much detail here. This is all there in the document. I'm going to switch gears now. So now you know about the connectivity stack and what that looks like, and what sort of this new level and the new bar we are setting, which is saying really we need syntactic interoperability as a minimum. This is state of the art. It's pretty well understood at this point, and that's sort of the minimum expectation you want to have. And then now the question is, how do you define long-term stable IoT architecture strategy from a connectivity perspective? So first thing, reality check. There's going to be many technologies out there, because there's already many out there. And there's new innovation happening. So how do we integrate the old and the new? Right. So I'm going to give you kind of a sketch here. So let's say I have this blue connectivity technology. Those circles represent endpoints or applications, and they're connected over some blue connectivity technology. So this is just a notional picture. I'm not saying what layer it is. I'm just saying it's some connectivity. And so the blues, and the blue applications can talk to each other, but they can only talk to the blue applications because it's their private language, right? And then along comes this red, another silo, and then now you want to open the data from the red to the blue and vice versa. So what do? Well, you can build a custom integration or bridge. Well, that's fine. That works. That will work for a while. But then you find another sort of interesting thing you want to bring into the table. Okay, so now you build 2 more translators. You have 3 of them, and then you have another one. So now you have a few more, and then a few more. So if you sort of continue with this approach, you quickly find that this is what we call order n square. It's a parabola, so it goes square of n being the number of different connectivity technologies, right? So then you quickly realize this doesn't work very well. This doesn't scale. So what do we do? How do we move forward? Do we stay stuck? Because this is where the industry has been stuck for years. And I've been, many people have come to me and told me, it's like, we are so happy that you're addressing this problem because we've just been going in a circle for the last 20, 30 years and so on. So this is where the connectivity reference architecture comes into play. And this is really saying, let's identify a set of core connectivity standards that act as the baseline, and we would have gateways from other connectivity technologies into these core standards. So what you're seeing here in this picture is a gateway from the green and the blue technologies here at the top, and then they connect to the core technology. Now, what the gateway allows us to do is open up the information from the blue endpoints, or the blue components, through the connectivity core standard back to the to the green one. So the blue and the green can now talk, for example, or exchange information. Right? So this approach can work. So that's viable. And this connectivity technology now, this coarse connectivity is like the lingua franca. Like, many of us speak multiple languages, but, we can communicate in English and that becomes a common language, right? So we can still speak multiple languages, but then, the English language becomes the core connectivity language for us, for humans, let's say. Okay. But what are the requirements of this core connectivity technology? Again, now we're going back to the Internet of Things, right? So it should not compromise, for example, syntactic interoperability, so it should preserve the fidelity. It should not compromise the functional requirements. It should not compromise the non-functional requirements, things like performance and scalability and so on, right? So now there could be more than one core connectivity standard or core connectivity technology. So here in this example, I'm showing a golden one here and then a green one. And so you could build a gateway to the green one or a gateway to the golden one, and that's fine. But then you also see this black gateway, and this is called a core gateway. You also need a gateway between your core connectivity standards. So as long as, now what we're saying is these need to be standardized, and as long as these exist, then you can build a gateway to any of the core connectivity standards, and they should still work together. Okay, so this seems like this may have some promise, right? What about we add a third core connectivity standard? Okay, well, now we need 3 core gateways. This still works. But pretty quickly you realize you can only have a few core standards in order for this to all work, because otherwise we go back to the same problem, right? So we expect that there will be a few core connectivity standards, but many gateways from many different domain-specific technologies. And as long as the number of core gateways, which is k, is much less than n, which is the total number of connectivity technologies, then if you do the math, it's k times k minus 1 over 2 plus n minus k, so it basically simplifies to order of n. So you've certainly taken that parabolic to a linear problem, which is basically saying, you essentially build n gateways. So basically, if you are a domain-specific technology, then you build a gateway to one of the core connectivity standards, and then because they are core gateways, you can talk to really any other endpoint. And now you've opened up your information model and information flow. So this gives you a basis for opening up and unlocking that data and really unleashing the potential of IoT. Now, the question is, what does it mean to be, what are the criteria for being a core connectivity standard? So there has to be a high bar. So we spent quite a bit of time thinking about that and, what core connectivity standards criteria should be. So we identified 10 of them. These are listed out here. Again, I won't go through each one of them here in the interest of time, but the first 5 really define those. The next 3 more technical, and then the business factors. And really, most of these are pretty obvious. And number 5 is interesting because it requires for a connectivity technology to qualify as a core connectivity technology, it should have core gateways to all the other core technologies. So it kind of is well defined mathematically, at least. All right, so now the question is, now we've got a foundation, right? We've got our stack, we've got the layers defined, the functions defined, the considerations there defined. We've got a way of embracing the old and the new. How do we go about selecting the right technology? And so we said, let's build some working models. So we put together some assessment templates. And the assessment template is really a 4-page worksheet. And it kind of guides you through a set of questions where a connectivity technology belongs. Because the technology may itself span multiple layers. It may not fit all the boxes exactly, right? It may span multiple layers, it may prioritize, it may not implement some functions, it may prioritize some considerations over others, and so on. It will have some level of impact on architectural qualities. It may make different trade-offs and decisions based on the use cases that technology was optimizing for. And then finally, how does it fit the core connectivity criteria? So that's a key part of the document as well. Chapter 6 is about assessment template worksheets. So you go through this list of questions. And so now we've got our model, we've got our foundation, we've got an objective way of assessing things, we've got our criteria and everything set up. Now, how does theory meet practice? Right, so now we're going to flip to the other side of the coin. So far, this was all about the science and the models. Right? Now let's look at the practice side. So let's look at the reality. Let's look at some of the standards. And so we asked, again, the membership, what are relevant standards, and this is again coming from IIC members, and the standards that were of interest are listed here in this first. So what we wanted to do was at least recognize some of the standards that members thought were relevant in this space at the lower layers, the access layers. Well, we didn't go into too much detail there, but we just put them here. So you see them below the network layer. Now the IP layer is the core standard for the network layer, right? It's the industrial internet of things. Then there's the usual suspects, the TCP and the UDP, which you see in the internet stack. Then sort of you start to see more specialized standards or more interesting standards that are more relevant for IoT. So there's DDS with its own messaging protocol called DDS RTPS that can be optimized for low latency over UDP or high throughput and wide area communications over TCP. You see OPC UA, which can run over HTTP, or it can be used with its optimized binary protocol over TCP. And then you see 1M2M, which comes again from the telecom space, and that doesn't define its own messaging protocol, but it can run over CoAP or MQTT. You see then web services, which runs over HTTP. So you see this range of standards, and there are detailed assessments in the document on DDS, on 1M2M, on OPC UA, on CoAP, on MQTT, on HTTP. So this is really a roll-up of the assessment templates and kind of shows you the placement based on which boxes light up when you answer the question about that technology in the assessment worksheets. And based on that, we just sort of put them in a picture here. Okay, so now you know how they light up. There's also this, how the criteria fit to these different approaches. So you can again look through this in the document. What's interesting is, again, number 5, you see these gateways emerging. Either they exist or they're in development now between these frameworks. So that's pretty exciting because that's great for the community, and it's advancing sort of where we go from here, how we go from here to there. There's also this table that, again, I think I'm running short on time here, but that talks about what's the sweet spot for each of these different frameworks. For example, DDS, it's targeting software architectures, software architects and software developers, and it's really optimized for software integration autonomy. There's OPC UA, which is really optimized for device integration and sort of configuring and plug and play type of devices. Then there's web services and web-based technologies, which are really widely used and well suited for mobile and web type of applications. And then there's 1M2M, which is really targeting ICT applications. So anyway, I'm going to wrap up at this point. Again, you can find all these details in the IICF. This is the connectivity framework. You saw the stack, the different layers. We raised the bar to syntactic interoperability, and then you can see the core functions and the considerations there. And really, this is the foundation to help us accelerate our IoT. So I would say, go ahead, after this, maybe you'll have a chance to download, so download it. Try to apply it, use it, and build your IoT, and we'd love to get your feedback. So, if you have a question, reach out to us. I think we'll have a way of doing that, and we'd love some input and feedback, and feel free to build your own assessments and maybe even contribute them back to the IIC. Here's a quick table of contents. Hopefully this all makes sense. There's a detailed FAQ as well. I'm around, so happy to answer questions, but I think my time is up, so thank you very much.